or hands-on wheel detection. Again, a classic task, as I mentioned, just to detect when the hands of the driver are not on the wheel. And if you guys think, and I urge you to just take 3 seconds and think of what would be the edge cases in this example, okay? What would be the edge cases for driving with hands off the wheel? So the data diversity that we envisaged in the first place are about the environment, the car types, the car interior, etc., the demographics of the drivers, the behaviors, so falling asleep, turning around, texting, holding the mobile phone in your hand, etc., and the scene, the background, the lighting conditions, etc. So you can see here at the bottom, this is just the flow that you would go through in the DataGen platform to generate this data. And as I mentioned, we have these as sequences. So essentially you get frame by frame, it's a 10-second sequence. You can get 30 FPS or even more. And each frame is fully annotated with the key points, etc. What we realized is that the first thing you want to do is to be able to label if the hands are on the wheel or off the wheel. And that's the initial analysis. So again, with synthetic data, it's super easy because we have the fingers key points, which by the way, are not part of standard data sets. For example, in Coco, you don't have those. The key points end at the bottom of the hand. And you have the 3D key points of the car wheel. And that is super easy to just to measure the difference and understand if the hands were on the screen or on the wheel or not. I hope you'll be able to see this very, very short video. You see the hand key points and how we can track if the hands was on the wheel or not. So that was super easy for our engineers. And then after the initial analysis, this is what we found. We found that the majority of misclassifications can be divided into several specific categories. So when hands overlap on the wheel, or where both hands were off the wheel, obviously. And the scenarios that we didn't think about were where the right hand is on the left side of the wheel. So you have one hand on the wheel, but it's not on the side that you would expect. And see various noises in the video itself. All of these were distractors for the model. So what the team did was basically just generate additional sequences for that specific scenario of both hands off wheel. So someone who's trying to navigate with other parts of their hands and not their arms, and where all the arms were off the wheel. And after retraining, performance on this specific scenario increased dramatically, as you guys can see.